Alright, so today we're going to be dealing with a motherboard that has no battery recognition. So it works, it turns on, it doesn't charge the battery, and it doesn't see the battery. This is an 820-2936 board inside of an A1278 2011 machine, aka a really old piece of shit, so I kind of don't know why anybody's interested in spending money to fix this, but for some reason somebody is interested in spending money to fix it, and as long as somebody's interested in giving me money, they have my attention. So let's go over this board. So let's go over some of the few things that you should understand when you're dealing with any type of battery issue. The first thing you need to understand is that there's a difference between not charging the battery and not seeing the battery. Not charging the battery could be a bad transistor, it could be current sensing issues, it could be the IC that actually controls charging is dead, whereas not seeing the battery, that's a battery recognition issue. And battery recognition issues are very different from battery charging issues. So I'm going to load up the schematic over here, and I'm going to go over one of the most basic, rudimentary things that you should check anytime you have this issue. All right. And as you can see, I finally found a way to mount the multimeter so that you can see it, which I'm sure if I knock on this thing too hard will come back to bite me in the ass. So, on to the schematic. So let's just get over to the schematic. Ah, that was loud. Yeah. All right, so here we go. So over here, you can see that the SMC talks to the battery charging chip, which is improperly labeled ISL6258 when it's actually an ISL6259. Thank you, Apple. And that also talks to the battery. This happens on this data line over here, and this data line is created by these pull-up resistors. If you don't know what a data line or a pull-up resistor are, I would highly suggest that you watch the video series I did on basic electronics where I explain what a pull-up resistor is and how it creates a data line. So let's see where these two resistors are. And let's see. So according to this, they're over here. Now let's see. One end of the resistor is going to be the voltage line, and the other end is going to be the data line. So the whole idea here is that these chips are going to talk to each other very similar to the way that Morse code works. You know, every time you think of it like the telegraph, you know, like every time you're tapping that little thing, you're kind of disconnecting the voltage for a short period of time, and that creates little blips, and those little blips are considered data, which is a god-awful explanation just because I'm honestly tired of explaining the same thing over and over again. But just go back and watch the video where I explained it because I'm doing a really bad job of explaining it right here. Anyway, so what I want to do is I want to see what the number is on diode mode on the multimeter. So diode mode on the multimeter is a special mode. So I go up to this little ohms reading over here, and then I'm going to click the yellow button until it gets me over to diode mode. Now what diode mode does is it measures the voltage drop across 2 points. So when these 2 points are touching, there is no voltage drop because, well, they're touching. Now, what I can do is I can take a board that works, and I can put the red probe on ground. And I can take the black probe, and I can put that on my data line, and I can try and figure out what the differences are. So let's try and check that out over here. All right, so first thing I have to do is get this microscope camera in focus because I see everything perfectly, but you can't see jack shit. Fucker, it's right out of focus. And I know as soon as I touch this thing, the damn microscope is going to fall down. The multimeter is going to fall down. That's how this works, you know. All right, here we go. Fuck, okay. And multimeter is trying to fall down. Nice try, mofo. Okay, so I'm going to get in focus in my eyes. There we go. And now we get in focus in the camera. There we go. That looks nice. All right. I love Open Broadcaster. I love that you can actually see what you're recording as you're recording it. So what I do is I take the red probe and I'm going to put it on ground, which here is going to be my screw hole. And then I take the black probe, and that is a nice fucking image. I love this new capture hardware. This is being captured in 422 losslessly. I know YouTube is going to destroy it, but still it looks cool while it's there. And let's see what number I get. Now you can't see the number I'm getting, so let's just go to that view. I can't even see the number. So I get 0.00. That's no good. That is a short to ground on that data line. And on the other one, I get 0.062. 0.062 is also no good. So what I'm expecting at these points is something like 0.442, 0.444, 0.468. Now, I'm not expecting that number out of thin air. It's not like it's like I went to college, and in college they teach you that if the SMC wants to talk to the battery, that the mode you're looking for that in diode mode. That's not how this works at all. Rather, the way this works is I take a board that works, I go, what is it supposed to be when it works, and then I compare it to this. Obviously, the line being at 0 or 0.002 means it's shorted to ground. So I don't need a working board to tell me that something's fucked up here. So one of the things in the line must be shorting to ground. So let's go over where this shows up. So what I'm going to do is I'm going to use my board view, and I'm going to type in N, which is for nets, which is going to show me everywhere in the board that this shows up. I'm going to go SMBus underscore SMC underscore BSA underscore SDA, and it's going to show me everywhere that this shows up. So what could potentially be shorting it to ground? So let's see, where are there attachments to ground here? So there's one capacitor on this line on this side that goes to ground, so it could be that. There's a diode right here that goes to ground, so it could be that. There's a few other areas here. Let's see. This software really sucks. This is some horseshit software. This is like playing Pac-Man with a liquid damaged arcade machine in the 80s. This is bullshit. There's this connector over here, and so if the pins are destroyed, could be going to ground. There's the U7000 chip, which is the battery charging chip that you see over here. This chip could be destroyed. Or it could be the SMC with its some 80, 90, whatever balls. Let's hope it's not that, because that sucks. So at this point, we know which different things it can be. So what I would do is I would just go a quick run over the board and try to see what area looks the nastiest. So this area looks semi-nasty. This is what I would call semi-nasty. However, it's not really nasty. Like this over here is nasty, so you can tell that pin, some not nice stuff happened there, but it's not really nasty. It's not necessarily shorting to ground. I don't see a short circuit between the anchor pin and that pin over there of the connector. So yeah, so the anchor pin is going to be this. This is what anchors it down into the board. That's why I call it an anchor pin. And I don't really see those shorting. Then we look over the SMC area, and okay, you got a little bit of crud over here, but this is crud for CPU vCore. This is not crud. This is not like, really widespread crud. So this area over here looks nice. You have this area down here. Okay, I can see that there's been some water here. There has been water, but the diode itself, a little bit of water, but nothing too nuts. And then we go up here, and let's look at the ISL 6259. Now there's red everywhere here. There's red really all around the chip. And what that red all around the chip tells me is that there's a good chance that this is what's doing it. So at this point, what I'm going to do is I'm going to remove the ISL, because I'm just taking a guess. That's really what this comes down to, is it's just me taking a guess. And remember, it could be anything on this line. If I really wanted to see what we're shorting it to ground, I could take my power supply and I could inject 3 volts. And I could inject 3 volts in the rail. I've done many videos on short detection, and then I could see what gets hot, but that's going to take a while. I could just remove the ISL in less time than it takes for me to try to do, short detection. So that's what I'm going to do here. So let's get on that. Just going to remove this nasty looking chip over here. I also should turn my JBC soldering station up. It's at 210 Celsius right now for something I was doing before. I don't know what the hell I thought I was doing at 210 Celsius. Yeah. Once I feel we've gotten reasonably hot, I'll just take you off. And now, let's turn off all this noisy shit. Really is noisy as hell. Oh yeah, the professional mount for the multimeter. Yeah, so let's see. If I get you between the tension and the zoom block, I'm good. Yeah, there we go. That's totally secure. It's a great way to put a $100 piece of equipment on top of a another $400 piece of equipment. There's like no production quality here. Wish I had more time. If I had more time, I'd put some production quality in. All right, so let's see if we fix the issue. So I'm going to take the red, put it on ground, and the black probe, and put it on the data line, and I get 0.445. Now that's pretty cool. Let's see how the other one's looking, because remember, there's two lines there. 0.436, that's fine. All right, so it could have been the ISL. And again, how did I choose the ISL? I simply went for the area that was most nasty. The ISL 625 line looked the most nasty. Therefore, I assumed it was bad, and that was that. So now I'm just going to give this thing a little bit of a cleaning, and also replace that shit. So, ugh, what a nasty looking, disgraceful area. So we have to get started cleaning that. All right, I got my flux back from the other table, and I also grabbed myself an ISL 6259. So let's get to some work. Let's get the air filter up and nice and close. Ugh. What a nasty, nasty board. I haven't ultrasonically cleaned this yet. I'm actually going to go put it through the cleaner after I'm done. So in addition to just replacing the chip, I'm also going to go over all these rusted pathways and just make them a little nicer. Scrape the oxidation away wherever I see it. There's oxidation everywhere. There's nasty looking shit. A smaller iron would kind of help with this. But I can get by fine with this one. Hey, nice try, mofo. Okay. That thing tried to fly away. We're not going to let it get away. There's barely any solder on that right pad. Okay, we get this into place. Now we get the new ISL 6259. I'm going to be selling these chips shortly. A lot of people have been saying, is there an alternative to buying from L2 if I don't want to buy from China? Very soon, it will be me. I hate selling parts, but I hate the idea of L2 making money even more. Let's push it down. It's not perfect. But all I care about now is that it's flat on the board. That's really my only concern in the beginning. Just going to go around it. Some flux. By some flux, I mean excessive flux. Anybody who's been watching the channel regularly knows that when I use the word some, that's just kind of an expression. It's not actually accurate. Okay, we go around. Get that ISO 6259 nice on the board. Go over every pin. Ideally slide the thing into place, because hell if that is even remotely close to aligned. Bleh. Awful. Yeah, this is going to be one of those awful soldering videos. As you can see on the lower left side, it's not actually there, right? Hey. Okay, and a customer walk. You unlock the password on my iPhone 3G. Go away. Go away. Okay, go. Yeah, this is the Hakko FM 2032 iron with the this is the T30-KN tip. My favorite. This makes the stuff a lot easier. Makes me look a lot smarter than I'm actually kind of an idiot. I can't get damn chip on straight to save his life. Okay, that's about as straight as this is gonna get. Now I know this is gonna work. So what I'm going to do is I'm going to ultrasonic this because it looks pretty shitty. So does it work? Well, you tell me. This is what we have after. Looks nicer than the before section. And delete that shit. And let's see, what do we have here? It's not plugged in. And what do you know? Works. So that's that. Hope you learned something.